In this video, we will be exploring some of the properties and formulas related to trapeziums. Okay, let's begin with the properties of a trapezium. Now, a trapezium is a four-sided figure and it only has one pair of parallel sides. Because if it has two pairs, then it will be a parallelogram. So now BD, in this case, is parallel to AC. The lengths of BD and CD are unequal, because if they are equal, then we will have a parallelogram again. We say that AB is not parallel to DC. Next, angle A and angle B, shown over here, they are actually interior angles that we have learned a few topics back. So they are interior angles bounded by parallel lines BD and AC. So when we add them together, these angles will give us 180 degrees. Reason: interior angles, parallel lines. Next, we also have the other two angles, angle C plus angle D, to be 180 degrees. Again, same reason, interior angles, parallel lines. Okay, now we will find out about the area of a trapezium. So by clicking on this link, it will bring you to this page. Okay, so here we can adjust the shape of a trapezium that we want. You're free to adjust any of this. And there are 5 different methods shown over here to derive the area of a trapezium. So now I'll be showing you for method 1. It has a name called parallelogram. Okay. So this being the original trapezium that we'll be starting off, our goal is to find this area. So if you click this, it shows you a point over here. You click on the slider. What happens over here is that it duplicates the trapezium that you have created. It makes a copy of it and it rotates it, and we arrange it in this manner. We see that this shape is now a parallelogram. Okay, let's rewind this. From any trapezium that you can create, we're going to duplicate it, we're going to rearrange it, and we end up with a parallelogram. So this can be done for any trapezium that we want. Duplicate, rearrange. Duplicate, rearrange. We will always end up with a parallelogram. Now we have already learned how to find the area of a parallelogram, which is the base times the perpendicular height. So if we know how to find the area of a parallelogram, base times perpendicular height, based on this simulation over here, we will be able to get the area of the trapezium by dividing it by 2. Okay, so that is the derivation of our formula for area of a trapezium. So to answer this, once we have the first trapezium, we duplicate it to get the yellow trapezium, we rotate it, and we join them up to get a parallelogram. So what is the area of this parallelogram? It is the base times the perpendicular height. Now, what exactly is the base over here? In this parallelogram, our base is A plus B. And our perpendicular height is shown over here to be H. Okay, this H is also the same H over here. Where did the A and the B come from? The B is the original base of the trapezium. The A over here is actually the top or the other parallel line from the original trapezium. So this gives us the area of 2 trapeziums. So if I just want one of it, then the area will be half times of this result, A plus B times the perpendicular height h. This over here, we have just derived the formula for area of a trapezium, and we usually read it out this way. The area of a trapezium is half times the sum of the parallel sides, in this case A plus B. We add them up and we multiply it by the perpendicular height. So let us try with some of these examples. Find the areas, all of them are in centimeters. So for part A, we need to identify the parallel sides. Area is given by half times the sum of the parallel sides, so 8 plus 5 times the perpendicular height of 6. Okay, so our first answer will be 39 square centimeters. Next, area is again half times the sum of the parallel sides, 3 plus 7, multiplied by the perpendicular height given to be 4. So 5 times 4, we get 20 square centimeters. The final trapezium, area is half times the sum of the parallel sides, 11 plus 5, multiplied by the perpendicular height. So again, just like in triangles, just like in parallelograms, the perpendicular height may fall outside of the trapezium, resulting in 72 square centimeters. These are questions on direct applications for the area. Now, please try exercise 2 and exercise 3 by yourself. The final answers are given over here. Again, it is the direct application of the formula. And we will now do exercise number 4. Here we have a trapezium in a wall of a bathroom. Okay, and AB is given to be 4.5 meters, BC is 3 meters, and they gave us the area. So our job is now to find the length of AD, which is the other parallel side. So we're going to use the formula. Area is half times the sum of the parallel sides, 4.5. No, that is the height. So that will be 3 plus the other parallel side, which is AD, multiplied by the perpendicular height of 4.5. This has to give us 18. So from here on, we can manipulate. 3 plus AD is the same as 18 divided by 4.5 multiplied by 2. AD will therefore be equal to 5 meters. Next, find the area of triangle ABC. So we are supposed to draw out the triangle ourselves. ABC. Find the area of this triangle as the percentage of the triangle ACD. So the other triangle in red over here. Earlier on, we found that this over here is 5 meters in length. Now, to find both of these areas, it is not difficult because we have the perpendicular heights for both of them already. So let us write down our calculations. Area ABC over area ACD. Half times of, for triangle ABC, base of 3, height of 4.5, divided by, for area of ACD, base of 5, height of 4.5. So we notice that there are many numbers that are common. So we can divide both numerator and denominator by 4.5. We can divide both numerator and denominator by half. So this over here is our ratio, but we wanted percentage. So we multiply this by 100%. So our final answer will be 3 over 5 times 100%, that will be 60%. Okay, now moving on to exercise 5. This will be your work to be done by yourself, but I'll give you some hint. So we've got a trapezium and a parallelogram. Area of the trapezium is twice area of the parallelogram. Form equation in terms of h, find the value of h. Now, area of trapezium, we already have the lengths of the two parallel sides. We've also got the perpendicular height. So the area of the trapezium can be found very easily from the formula. So they say that this area is double that of the parallelogram. So whatever this area is, we divide it by 2, we will obtain the area of this parallelogram. Now, with this area, we have to find the value of h. We notice that h is actually the perpendicular height of the parallelogram if we choose 6 to be the base. So from then on, we can form the equation in h and solve for h. Next, exercise 6. Exercise 6 is also work to be done by yourself, but again, I'll give you a hint. We've got a trapezium with AD being 12, and take note, BC is 18. So it stretches all the way to B. This is 18 centimeters. And they tell us that the area of triangle ABC, so ABC, we need to draw a diagonal line ourselves. This particular area is 63 square centimeters. So we see if we choose BC as the base of the triangle, then AE must be the perpendicular height. So using the formula for area of a triangle, half times the base times the perpendicular height to get the area, we can work backwards and find the length of AE. So that is not a problem. AE is the perpendicular height of the triangle. At the same time, it is also the perpendicular height for this trapezium, which is what we require to find the area of ABCD. We've got the parallel sides, 18 and 12. All we needed is AE for the perpendicular height, which we said that we could have found. Okay, this is the final question of the notes. Here we have a rectangular board, 20 cm by 15 cm, and AE equals to BF, which is X. So they cut out a trapezium to form the side of a little bean, express EF in terms of X. So we see that EF is actually 20 over here, since this is a rectangle, total length 20 minus X minus X. So that will be 20 minus 2X units cm. Next. Okay, so let's take stock. We now have the expression for one parallel side, we have the other parallel side, we have the vertical height of the trapezium. So now they tell us that area of this trapezium is 3/4 that of the rectangle. So we write this down in numbers. Area of CDEF, meaning half times the sum of the parallel sides. So that will be 20 plus the other parallel side is 20 minus 2x. Whether you put brackets here or not doesn't make a difference. So this is the area of the trapezium CDEF. This is equal to half times the sum of the parallel sides multiplied by the perpendicular height. So we missed out the 15, and this is equal to 3/4 of the area of the rectangle, which is simply 20 multiplied by 15. This is our equation in X. Okay, form an equation in X and find the value of X. So looking at this, we have one equation with only one unknown of X. So let's go ahead and solve it. In the bracket, we have 40 minus 2x. This is multiplied by 15. And on the other side, we have 225. Continue simplifying, we multiply by 2 on both sides to get rid of this half. At the same time, we divide by 15 on both sides to remove this 15. Therefore, left hand side we are left with 40 minus 2x equals to 225 times 2 divided by 15 results in 30. Okay, so let me put it now. Over here what we did was to multiply by 2 to get rid of this half. So on the other side we also have to multiply by 2 to ensure they are equal. Then we divided by 15 to remove this. So we divide by 15. Continue solving. We will arrive at x equals to 5. Okay, there are a few steps that were skipped, but you can figure them out by yourself. And there we have it. That is the end of this set of notes.